Good morning, class. Please get right to work on the warm-up. You'll notice this morning I'm asking you to please get up one table at a time to get your computer and start it up. Remember, you are supposed to use the computer assigned to you. There is a sheet up inside the computer cabinet that will remind you what your number is if you have forgotten. I will pause the video now while you work on the warm-up problems and get your computer for the next 5 minutes. When we go through the solutions, you will not have time to write down every single step if you haven't gotten a start on these problems. For instance, look at number 4. If this seems overwhelming to you, then a good place to start is by factoring each piece of it, however you can. So 3x squared minus 12, can you at least write this problem with those terms? 3x squared minus 12. Can you put that in factored form here? Okay, I will pause the video now while you begin work on the warm-up problems. Now that you have had time to work on the warm-up problems, let's look at the solutions. On number 1, we can use the technique of cross multiplication that we discussed in a recent class. So when I cross multiply, I multiply on the diagonal, and so I get 7 times 5 is equal to 5x times 14. Simplifying that gives 35 equals 90x. This one's not going to work out to be a beautiful number, but it will be our solution nonetheless. Divide both sides by 90, and then let's simplify that 35 90ths over here down to 7/18. To solve number 2, we need to use a common denominator. As I look at this, I determined that the common denominator that I can use for this equation is 6, which means if I do not have a denominator of 6, such as in this term, I need to multiply both top and bottom by the missing factors so that I will get that. So let's look at what we start with. I've spread this out to give myself some room to write the missing factors. Looking at the first one, what's missing from the least common denominator is the factor of 2. So I'm going to multiply times 2 over 2. Looking at the second term, I'm not missing anything, so I can leave it as is. And then looking at the expression on the other side of the equal sign, it's missing a 6 in the denominator, so I'm going to multiply both top and bottom by 6. Simplifying this yields 4x over 6 plus x over 6 equals 30 over 6. The idea we began discussing in the last class was that once we have a common denominator, in this case 6, we can essentially ignore it and just deal with the expression, the equation on top. So our problem really now becomes, what is the solution to 4x plus x equals 30, the highlighted expression? So let's quickly work that out. 4x plus x equals 30 simplifies to 5x equals 30. Divide both sides by 5, gives me my answer of x equals 6. Moving on to the next problem, making sure we can still remember how to identify domain, holes, and asymptotes. The first step is to find this function in factored form, and so I have done that here. So x minus 4 over x plus 4, x minus 4. And then I can cancel out the x minus 4 over x minus 4, which simplifies to 1 over x plus 4. The domain is all numbers such that this denominator is not undefined. And when I see that in factored form, I can identify that the domain excludes 4 and the domain excludes negative 4. There is going to be a hole at x equals 4. Let's see, little problem with the sign here, right? The one that canceled was the x minus 4, so what's left of my denominator is x plus 4. Remember, the hole will occur if there was a factor that disappeared. So this x minus 4 is not in my final answer, but it would be problematic if I were to plug in the value of x equals 4 because it would produce an undefined expression. So there will be a hole in the graph there. And then there will be an asymptote where the expression, the simplified expression, is undefined. The simplified expression is undefined when x is equal to -4, and so that is where I will find an asymptote. Let's just quickly check in with the graph and make sure we have validation that we've found the correct values here. Checking in with the graph, and a table of values confirms that there is indeed an asymptote at x equals -4, and there is a hole at x equals 4 because the expression is undefined there. Finally, let's look at this last problem. I asked you if you were stuck to at least try factoring the different components of the expression. So let's begin by just looking at this. Don't worry yet about some of what's written on the right. So I have simplified x cubed, stays the same. Factor this becomes this. This factors to this. And this factors to this. Let's look at where these are in the next expression. That's still in the numerator. This is still in the denominator of the top expression, but notice I've factored it further. And then now let's look what happens with a complex fraction. Remember that this is saying this top fraction divided by this bottom fraction. So I am going to invert and multiply this bottom fraction in order to solve the problem. So keeping track of where everything is here, the orange highlighted here has moved to here, and the purple highlight, after inverting, has moved to the top. Notice that I've also done an additional factoring step, moving from here to here. Once we're to this point, we can simplify any common factors, cancel them out. X cubed will cancel out, so x squared will cancel all but one of those x's. This 3 disappears. So now let's go through and see what factors are left. On the top, the only thing left is this x, and down below, the only thing left is this x plus 2. So this whole expression simplifies to x over x plus 2. By now you should have your computer started up, and we are going to do some quick practice with the active expression to make sure we're all comfortable with that technique.